Hi there, this is Electromagnetism Lesson 7 and this is transformers. So we're going to give examples where we find transformers, label the different parts and explain in detail how transformers convert alternating current at a certain voltage to a different voltage on the secondary coil. So it's basically an explanation of how they work. Comes up on exam questions, normally 4 or 5 mark response required. So let's get into it. So different examples of where you find transformers. So top left is power station. You should have a basic understanding that transformers are to increase voltage or decrease voltage. If they increase voltage, it's a step up transformer. If they decrease voltage, it's a step down transformer. You should have covered that when you should have studied the national grid, obviously before electromagnetism. If not, I'll go into a little bit more detail on the next video on step up and step down. So mobile phones, chargers, they have a transformer inside to obviously reduce the voltage from 240 volts on main supply down to, on this one you can see it's going down to 10 volts. Alright, let's carry on. So power can be transferred between circuits using 2 coils wound around a soft iron core. It's called a transformer. So here's a basic setup. This is a step-up transformer because on the left-hand coil, which is the primary coil, there's less coils, and on the secondary coil on the right-hand side, there's more coils. So that's a step-up transformer. It's going to increase voltage. Right, so oops, I meant to do that. Right, so basically you put a alternating voltage on the primary coil, which would induce an alternating current in the primary coil. And obviously you should already know that, due to the right-hand rule for wires, that when you put a current through a wire, it produces an associated magnetic field around the wires. Now what happens is, so you'd end up with obviously because it's an alternating current, you'd get an alternating magnetic field. So that magnetic field will reach out across the transformer, and the magnetic field will interact with the secondary coil. Now you should know from previous lessons that when you get a magnetic field interacting with a current carrying conductor, in this instance a coil, you'll get electromagnetic induction on the secondary coil. So if you want to make some notes, please remember to pause and then we'll move on. And just in case you see one of these, this is the circuit symbol for a transformer. Right, so a transformer links 2 circuits together. So the primary side, as I've mentioned, is simply an electromagnet. So you pass current through it, or an alternating current, and it'll create or generate a magnetic field. Now it's an alternating magnetic field, so the polarity keeps changing, but essentially it will cut the secondary coil, then not cut it, then cut it again, then not cut it, then cut it again and not cut it, and it'll keep alternating. The field keeps changing direction. Essentially it'll come out, if I can draw this in, so your field kind of gets set up kind of like this. Alright, those field lines obviously shouldn't cross, and what those field lines do is they cross the secondary coil. So the primary side is simply an electromagnet. By passing electric current through the coil of a wire, makes a magnetic field, just like we've looked at with bar magnets. Now, if we use a direct current, which is DC current where the current only flows in one direction, the magnetic field would be set up, but then just stay there. So if it just stayed there, you'd get some initial electromagnetic induction on the secondary coil, but it'd only last for a split second, and then, if the field's not moving, then there's no electromagnetic induction. So the fact that it's alternating, this field will keep switching directions. Alright, so let's say that with the north side, that's the south side. It'll flip, this will become south, this will become north, then it'll flip again, north, south, and it'll do that really rapidly. And because that magnetic field's, cutting the secondary coil, we get electromagnetic induction. So the secondary side coil is not connected directly to the primary side or any power supply. So just to reinforce what I've been talking about, the secondary side works using electromagnetic induction, when the magnetic field is perpendicular to the secondary coil and changes, so it's that alternating thing that's really important, we get an alternating voltage and an alternating current induced in that secondary coil. So again, when there is an alternating current in the primary side, the magnetic field around the transformer alternates, as I've already stated, which then leads to the alternating voltage and the induced alternating current in the secondary coil. So it's basically a two-step process. I advise you read through that carefully, make any relevant notes, and then I'll move on. Two important points before we go to a kind of a good example that you might give in an exam for an explanation of how a transformer works. So important points that you might be asked on is, number one, the core is made of soft iron. Remember, we've talked about this before, softly magnetic, because it is easily magnetized and it's not a permanent magnet. The fact that it's so easily magnetized, it's also easily demagnetized. Second one, the wires are insulated, so the coils are actually insulated. If not, then you would get a short circuit. Short circuit is when the wires connect to each other. I'll give you a little example. So let's say we had a really simple circuit. So we've got a cell there and a lamp. So the current normally will just go through the lamp, light it up. If we short this circuit, which literally means shorten the length of the circuit, let's say I put a wire in there, the current would then go that way, wouldn't go through the lamp. So the same kind of thing happens with the coils. If the coils are, tightly wound together, not insulated in any way, current can just pass through rather than going around the coils like it should do. And you can be asked these in an examination. I've got some exam questions to look at in a moment. All right, let's move on. So this is the response that I would give to get 4 marks on an examination question. Depending how you learn, or you might understand the process perfectly, so you won't need to memorize this or go through it, but you might need to write this out a couple of times, just to make sure you understand it. So first of all, you want to say an alternating voltage is set up across the primary coil. Number 2, this induces an alternating current in the primary coil. Thirdly, this sets up an alternating magnetic field inside the iron core. And then we're moving on to the secondary coil with the electromagnetic induction. So you get an alternating voltage set up across the secondary coil, which of course induces an alternating current in the secondary coil. You can mention in between steps 3 and 4, you could talk about electromagnetic induction, because that's essentially, obviously, what's happening. All right, let's do some questions. So if you want to pause on the question, write your answer, and then I'll obviously give an explanation, give you the answers. So the basic structure of a transformer is a primary coil of insulated wire, an iron core, and a secondary coil of insulated wire. This is a step-down transformer because it's going from more coils on the primary coil to less coils on the secondary coil. The question simply asks, why is the core made of iron? And we've just discussed that. It's perfectly fine to just say quickly or easily becomes magnetized. Or you could say quickly loses its magnetism. Right, so explain how a transformer works, 4 marks. So you should have this written down. You might try and do it without looking at your notes. So mark scheme. So the points that we talked about earlier is, on the primary coil, you have an alternating voltage, which isn't in this part of the mark scheme. That would induce an alternating current in the primary coil. This induces an alternating or changing magnetic field inside the iron core. If you've mentioned electromagnetic induction, that's fine. So induces or produces an alternating potential difference or voltage on the secondary coil, alternating current on the secondary coil. So the method that I gave, or the explanation that I gave, will match any mark scheme that I've seen over the last 15 years. You'll get 4 marks for it. Okay, hopefully that's all right. Thanks for watching, and I'll speak to you soon.